Nanyang Technological University, Singapore is a research-intensive public university with 33,000 undergraduate and postgraduate students. It's home to the Institute for Sports Research, which is a sports R&D centre focused on creating new sports solutions through science and technology. The Institute for Sports Research is supported by the schools of Mechanical and Aerospace Engineering and Material Science and Engineering of the College of Engineering, and the Physical Education and Sports Science Group of the National Institute of Education. I'm a researcher specialising in footwear R&D. I apply my background in biomechanics and sports engineering to understand how the mechanical aspects of footwear influence the individual wearer's movement and feel, and then I offer technical recommendations. Runner Camp approached the Institute for Sports Research to help develop their shoe selector matrix, which aims to narrow down the shoe models that match the individual wearer's needs. We built a database of running shoes from the last 2 seasons and put each of those shoes through a series of mechanical tests. We then scored each shoe for each parameter and passed all that information on to Runner Camp to inform their shoe selection matrix. In the cushioning test, we perform a free-fall impact of the shoe against the surface. We measure the force and the compression that the sole experiences. We're then looking at the degree to which the sole reduces that impact. So we apply a vertical load of 800 newtons to the forefoot region of the shoe, and then we slide that shoe along 2 different surfaces. The first one is the asphalt road, and the second one is the tartan running track. We measure the vertical and horizontal forces, which will give us an indication of how much grip there is between the shoe and the surface. So this is the forefoot stiffness test, and here we flex the shoe along the joints of the toes. We apply a force and we measure how much the shoe flexes. This will give us an indication of how stiff or flexible the shoe is. So if you have a very flexible shoe, your foot's going to be moving more naturally and your foot will be doing most of the work. If you have a very stiff shoe, your shoe's going to be doing most of the work. This is the torsional stiffness test. What we're looking at here is the coupling between the heel and the forefoot of the shoe. What we do is we see how much force is required to rotate the shoe through 10 degrees. Let's say if we need to apply a large amount of force, we're going to have a shoe that's greater in torsional stiffness. If we have a shoe with a low torsional stiffness, there's a greater range of movement that's available between the rear foot and the forefoot, and it offers a more natural movement. So in summary, these 6 parameters tell us how the shoe will behave under dynamic conditions. We take all this data and we share it with Runner Camp, who apply it in their shoe selector logic.